All right, this one looks fun. We got a lot of 7s and even a 5. All right, let's get involved. Okay. So when we see this first step, we want to.
This is over 5.
Remember, we want to differentiate this, which means to find the first derivative, the instantaneous rate of change, f prime of x.
Okay.
Whatever you want to call it.
So 7.
Good. Power rule.
Yeah, I'm not sure from here.
From there. So don't forget this is a chain rule. All right, you look up the power rule. Now you gotta make sure you do the derivative of the inner. All right. So the derivative of the inner. The inner is what? What's the function for the inner?
Secant of x.
Secant of x, right? So know the derivative of that?
No.
You don't?
No.
Ooh, I can teach you a fun little trick.
Okay.
Here, I'll teach you this little trick. Here at Mathematician, we call it psst. So look right here. P-S-S-T, like you're whispering to someone. Look at these last 3 letters. It's going to be secant, secant, tan. And then right under cosecant, negative cosecant, cotangent. So what you do with this, these are in a specific order, you have to remember the order. So any number, any trig function, the other trig functions in its row, that's what its derivative is. So for example, look at tan. The derivative of tan is secant squared. Look at negative cosecant. The derivative of negative cosecant is cosecant times cotangent. See how that works? The derivative of secant is secant tan, which is the one we're doing. You see that? Like that little trick? It's pretty cool, huh?
Yeah.
We call that psst.
So this one would be secant tan.
Exactly, secant tan. Nice work. So you can apply the same rule to this next part of this. Well, sorry there, Sonny boy. It seems like my writing got in your way. Nice. You applied the same rule, the power rule, and the chain rule.
I can cancel these out too.
Oh, good eye. You sure can. Now you can get rid of those. That'll be good. No more denominator.
I'll just multiply these out. Is that okay?
You can absolutely multiply that out. Get it back to the secant to the 7th. Good, good. Let's look at that next step. See if you can find any identities there. See if you can factor it out. Secant, yeah. How many secants?
X to the 5th.
Yeah, well, yeah.
So we can factor that out.
You're going to factor that out. Secant to the 5th of
and
x.
The tan x.
Tan x, because of the tan x in both terms. Good.
So we're going to have a...
What are you going to be left with there?
Secant squared.
Secant squared, good.
X minus 1.
7 minus 5. Minus 1, exactly, because you took the tans out, and there's no tans left in the secant to the 5th. Good job. And so what are you going to do from here? Know the next step, Sonny boy?
No. Oh, this is an identity.
Nice, it's an identity.
So
one of our fundamental trig identities.
To the 5th x, tan x.
Yeah. And what happens to that? Secant squared of x minus 1. Little
That's
identity.
Tangent squared x.
Tangent squared x. Good job.
So
you know your identities. So what are you going to do from here? Can you find any common factors like terms? How can we simplify this? I think you can multiply together to get us maybe 1 term instead of being 2 terms being multiplied.
Yeah, I could do secant to the 5th x. Tangent cubed.
Tangent cubed, right, because when you multiply, you're going to add the exponent. Good job.
Well, secant to the 5th x is 1 over cosine of the 5th x.
Right, it's 1 over cosine.
And that's multiplied by...
What's tangent? What's that?
Sine over cosine.
Sine over cosine. Don't forget the exponents.
Yep.
Oh, good job.
And then this will just multiply out to sine cubed of x over cosine to the 8th of x.
Cosine to the 8th of x. Good job. Is that fully simplified?
I think so, yeah.
Yeah, you're right. Good job there, Sonny boy. Nice work. Alright, so again, at this next problem here, we're dealing with integrals now. Moving on to that 3rd unit, that 3rd major component of calculus. Alright, so let's see. The integral from 0 to 1 of x squared times x cubed plus 1 quantity cubed times dx. So, let's see. Ooh, this is going to be a fun u substitution problem.
Okay,
you know about u substitution?
Yeah.
You do, really? So what do you think your u would be, your innermost function?
Probably the x cubed plus 1.
X cubed plus 1, right? Because it's the innermost function. Nice work. So remember, what do you do when you find u? You got to find the derivative of u, right? We call that du.
3x squared dx.
Dx, yeah, good job. So you took the derivative, and the 1 becomes 0 because it's a constant. Alright, so now we want to plug in the u and du in for the x and the other x and the dx. So let's see if you can plug that in.
Should I first factor out a 1/3 though?
Yeah, you gotta make sure you factor out the 1/3. Of course.
Oh yeah, so here we have the x squared and the x squared.
Mm-hmm.
And those will cancel.
Those will cancel.
Okay,
and also the dx for the du.
Pull the 1/3 out front.
So it all looks good except for one small problem I see there, and it's with the bounds. So the bounds are going to change in this step because we're changing the integral function to be in terms of u as opposed to in terms of x. So what we're going to do is we're going to plug in these x intervals on the integral into the u sub equation, and then those will be our new boundaries, all right?
Okay.
So we're going to plug in 0 into u. What are you going to get when you do that?
Plug in 0 into u or 0?
Or into x,
okay.
into the u sub equation.
So u 0 cubed plus 1 and u equals 1 cubed plus 1.
Mm-hmm.
So for this one we'll get 1, and for this one we'll get 2.
Exactly. So those will be your new bounds from
Okay.
1 to 2. Nice work. So now what do you think we're going to do next? What's the next step here? So I'll give you a hint. You're going to use the integral now. You're going to integralize the function.
Okay, so we'll have 1/3 times 1/4 u to the 4th from 2 to 1.
Let's see here. 1/3 times 1/4. And nice.
So
I like how you skipped a little step there. You're a speed racer.
U to the 4th from 2 to 1.
Nice job, right? So now we're going to have to finish the problem out with plugging in the bounds for the u. Or maybe we should plug the x back in. Who knows? Let's see what you got for us. What you got in store. Good job. Nice work. Let's keep simplifying that. 2 to the 4th. Nice. Good job. 15 over 12. Yeah, you circled something, but I don't think that's fully simplified.
Oh yeah, you're right. 5 over 4.
That. Yeah, because 3 goes into both. 3 goes into 15 5 times. 3 goes into 12 4 times. Nice work, Ellis. Let's take a look here. It seems like we got an integration problem. We need to evaluate this integrand. Let's see what you got. You know what to do for the first step, Ellis?
Seems like you could multiply these together and add the exponents.
You can simplify it before even taking the integral or integrating. All right, yeah, good job with simplifying that. Now see if you can take the integral of that function. You can integrate it. Let's see.
And that's the same.
Nice. Yeah, dividing by that. You did the correct power rule. Good job with the power rule. Multiply by the reciprocal, and you. Good formatting. You changed the integral to be on the right side. Good job. All right, so what's going to be the next step after this? Furthering the integration of this function. Good job. You're going to plug in that. Nice work. So now it's going to be our next step. Think of what you can do here.
Can I use my calculator for this?
Sure.
Okay, so 9 to the power of 5 over 2 is 243.
Look quick on the calculator. You're like a walking calculator.
This will be 32.
Nice, right.
And then, so 2/5 times 211.
Don't be too reliant on that calculator, though. Can't have that for everything. Good job. Alright, Ellis, so you did a good job with this problem, but I'm going to show you a trick that you can use so you don't have to use a calculator for when you're doing this problem, this exponent. So it's a little change in form. So a 9 to the 5 halves, you're going to move this 2 to be the number of the square root, or of the root. So this is going to be square root because it's 2, right? Does that make sense? And the 5, we're just going to keep that here, and it'll be to the power of 5.
Okay.
And this is the same thing. These are the same things. So what's square root of 3? You know that one.
The square root of 9?
Square root of 9, yeah.
Yeah, 3.
It's going to be 3, exactly. God, I helped you. You don't deserve credit for that. All right, we're going to move on. So now we have to do, it's going to be 3 to the 5th.
Uh-huh.
So we'll make a little table for this, figure this out.
Okay.
So we'll start with, this will be what's to the first of, so, or the power, so it'll be to the first. 3 to the first is what?
3.
3. 3 squared.
9.
9. 3 cubed.
27.
27. Nice. What about to the 4th? I think we might know this one. There'll be 81. Now we just have one more to go because 3 to the 5th. So what's going to be the 5th? It's going to be 81 times 3. 3 times 1?
43.
2. Wow! Nice job, Ellis. So that's going to be that answer. So therefore, 9 to the 5 halves is 243, the same answer you got from the calculator.
Okay, cool.
And the same thing with the next one. Let's try that one out. So it's going to be the square root of 4 to the power of 5. All right, so what's going to be, what's the square root of 4?
2.
2, right. All right, and that's 2 to the 5th, right?
Which is 32.
Which is 32. Right, exactly.
I knew that
one's a
one,
bit
yeah.
easier. Nice job. Equals 32, and that's the same answer from the calculator.
Cool.
Good job, Ellis. So, Ellis, I just wanted to say we really appreciate you coming in. I think we had a great time here, and I know as part of the Mathnasium family, we would just love to have you back in here whenever you need more help with math.
Thanks. It was
Yeah,
really
good-
helpful.
Yeah, good luck on your final. I think I'll do really well. You're really starting to get the hang of these integrals, derivatives, and limits.
Yeah, thanks for the
All right.
help.
Yeah, of course. Good luck.
Thank you.
Take care, young man. Oh, Ellis, can you please meet me in the study?
Hey, Dad.
Hey, son, how's it going? Take a seat, please. So I have some good news. I just got an email from your AP Calculus teacher. What do you think she told me?
I don't know. What'd she say?
You got a 98 on your final in Calc.
Really?
Really?
Oh my god, that's so awesome.
Yeah, it's going to help you a lot since you failed the midterm.
Yeah.
I'm really happy for you, son.
Thanks,
Mathnasium works wonders.
Yeah, thank you.
Next time you're struggling, just let me know and we'll help you out, alright? Don't try and carry all this burden. Come to your parents and we'll help you.
Thanks, Dad.
Alright, go and play around, you little heck raiser. I'm proud of you, son.